Hi everyone. Today we have a question from November 2015. That is the question here. This question is related to organic structures, IUPAC naming, and the isomers. The letters A to D in the table below represents 4 organic compounds. Before we go into the questions, let us just identify what we have in this table. When we look at compound A, you can easily see this triple bond between carbon atoms, so that compound A is an alkyne. It belongs to the homologous series of alkynes. When we look at compound B, we see that unusual part of carbon double bonded to oxygen, and around it, as you see, you have 2 other carbon atoms, no hydrogen atoms, only 2 other carbon atoms. That makes this compound to be a ketone. Ketones have the functional group of carbonyl group. When we go to compound C, we have here CHO. If we write the structural formula for this end part, it should be a C double bond O, and on this side we have H. So that this is a formyl group. Formyl group makes it an aldehyde. And lastly, we have butane. The suffix tells us this is an alkane. Now use the information in the table to answer the questions that follow. Write down the letter that represents a ketone. A ketone is the compound B, we just identified. Structural formula of the functional group for compound C. I actually wrote it there. Let me rewrite this. The compound C is an aldehyde. Aldehydes have a formyl group as the functional group. And this is the structural formula. If it was asking the name instead of structural formula, we would say formyl group. But here it's asking structural formula, then we go with this structure. General formula of the homologous series to which compound A belongs. Compound A is an alkyne, and the general formula for alkynes is CnH2n-2. IUPAC name of compound A. Compound A, we say it is an alkyne. To write the IUPAC name, firstly, we choose the longest carbon chain. That is my longest carbon chain. We need to number the carbon atoms, and I have to start from the right side because my functional group, triple bond, closer to the right side. So here we go. 1, 2, 3, 4, 5, 6, and 7. I have a chain with 7 carbon atoms. And then I have a substituent here, and I have another one on the 5th carbon. The one on the 5th carbon is a methyl group, and the one on the 4th carbon is an ethyl group. Ethyl, as the alphabetical order, comes first, so I must start with the ethyl group. 4 ethyl, and it is followed by methyl, which is on the 5th carbon, 5 methyl. And here I have 7 carbon. 7 carbon is normally heptane. But what we do, we remove this ane suffix. We are gonna replace it by ine. Where is my triple bond? It's on the 2nd carbon. So I mentioned the position of triple bond, and we add the suffix of ine. Okay, here we go. So the IUPAC name is 4-ethyl 5-methyl hept-2-ine. An IUPAC name of compound B. Compound B is a ketone, we said. Let us number the carbon atoms. I can use a different color here. 1. The functional group closer to the right side, so I start from right again. 3 and 4. 4 carbon is normally called a butane. But what we do for the ketones, we remove only E suffix. We mention the position of carbonyl group, which is the second carbon, and I add on suffix for a ketone. So the name goes as butane-2-on. That's the IUPAC name. And then compound D is a gas used in cigarette lighters. Compound D, what was it? It was butane. Here I need to mention alkanes from 1 carbon up to 4 carbon are all gas at room temperature. So methane, ethane, propane, and butane, they are all at gaseous state at room temperature. To which homologous series does compound D belong? D belongs to alkane homologous series, alkane family. Write down the structural formula and IUPAC name of structural isomer for compound D. Okay, here we go. Compound D, let me start with compound D first. Butane, right? Butane is CH3, CH2, CH2, CH3. A straight chain 4-carbon alkane. This is butane. Now we are trying to get an isomer, a structural isomer. From this straight chain, I can make a branched chain, and that will be my structural isomer. On the second carbon, let me say structural formula. So let me shift to the structural formula. Here we write first carbon. This is my second carbon, and I make a branch on the second carbon as a methyl group. So I made my branch, and then I have 1 more carbon atom. So we have 3 carbons in the chain. We add the hydrogen atoms to make each carbon have 4 bonds. And this one needs 1, 2, and 3. This is the structural formula of structural isomer of compound D, this molecule, and the name is for this compound. Here we have 1, 2, 3 carbon atoms. I have a methyl on the second carbon, so I say 2-methyl. And the chain has 3 carbon propane. So basically, 2 marks goes to the structural formula and 2 marks for the IUPAC name. And the next question is the isomer in question 2.2.2, a chain isomer, positional isomer, or functional isomer. Here, as we obtained a branched chain from the straight chain, we call it a chain isomer. So it is a chain isomer. All right. So let me move this a bit down. I think it will be better if I erase everything. Yep. Now the last part of the question. This part says compound D, which is butane again, reacts with bromine to form 2-bromobutane. The reaction happens just like that. when I'm thinking where to write down this, okay, just a second. Yeah, this will be a better space for me. All right, compound D is CH3, CH2, CH2, and CH2. When it is reacted with Br2, here we need a catalyst. We will learn this later on, but now I can mention that alkanes are, as they are saturated, alkanes are relatively inert. They do not easily react with anything else. To react with a halogen, we need a light or heat. So here we need UV light. When this reaction starts, the halogen atom replaces by one of the hydrogen atoms. So the halogen atom goes to this carbon and a hydrogen atom is removed. So basically, halogen comes in and kicks the hydrogen out so that we obtain a molecule CH3, CH2. Here we have CH now. It was CH2. When we remove a hydrogen, it becomes CH with the addition of Br, and then we have CH3. Then this hydrogen, which is removed, joins to the remainder of this Br and forms the HBr. And this kind of reactions are called a substitution reaction. As we add something and remove something, we call this reaction a substitution reaction. As in this case, we deal with a halogen, you can call it a halogenation as well. You can even call it a bromination reaction. Okay, let me go back to question. Write down the name of homologous series to which 2-bromobutane belongs. 2-bromobutane. Butane is an alkane, but the presence of bromine makes it a haloalkane. So here we have a haloalkane. And the last one, type of reaction that takes place, as I mentioned, this one is a substitution. You can call it a halogenation. You can even call it a bromination reaction. That's all for this question, guys, for today. Thank you so much. See you soon.